Hello, my name is Bettina McDowell and I am the IWMA General Manager. Today I will talk about how water mist works. I will say something about the benefits of the technology, I will list some applications, and I will tell you a bit about the history of water mist. You most probably know that a fire triangle comprises 3 elements. However, the fact that water mist reduces 2 of these elements, that is the heat and the oxygen, may be something that you did not know. And this is actually the first take-home message. The second take-home message is that water mist is a performance-based technology, which means that you will always get a bespoke system for your application, which is based on a real-scale fire test, not on computer simulation, because water mist is not a one-fits-all concept. When it comes to the definition of the different water mist systems, you can see on the right-hand side that low-pressure systems work with a pressure below 12.5 bar, and high-pressure systems work with a pressure above 35 bar. Systems ranging between these 2 figures are defined as intermediate pressure systems. Now, this is according to FM 5560 and NFPA 750, 2 North American standards, VDS, and you may be aware of the VDS guideline 3188. See, that's slightly different. VDS say that there are merely 2 systems, low pressure systems that remain below 16 bar or 232 psi, and high pressure systems that exceed 16 bar. What may also be interesting for you is that nowadays high pressure systems work with up to 200 bar, as I already said, but a few years ago that figure was much lower, so there could well be room for further development there. Low pressure systems are obviously much closer to traditional sprinkler systems, and indeed sprinkler components can be used. There are fixed systems, fire brigades use water mist, there are water mist fire extinguishers, there are water mist lances, guns, turbines, trolleys. Some nozzles are fixed to ceilings, others to walls, so quite versatile. Here you can see that NFPA, the National Fire Protection Association, and then the European Committee for Standardization have a slightly different opinion when it comes to the number of droplets that should be less than 1 millimeter or 1000 microns in size. However, what is more important than the question whether 90% or 99% of the droplets are less than 1 millimeter in size is the fact that water mist is obviously defined by droplet size, and that the droplets that water mist systems produce interact with the fire in a different way than the larger droplets produced by sprinkler systems. The droplet size is a result of the pressure of the system, but also of the type of nozzle, and what I would like to stress, the smaller the droplets, the quicker they evaporate. So how does that all fit together? What happens if a fire breaks out and the water mist system is activated? Water mist attacks the fire by spraying water through nozzles especially designed for this purpose. The smaller the droplets, the larger the overall surface, and in a fire incident, after a system has been activated, the droplets evaporate and turn into steam, and thus the system reduces the temperature and the oxygen. In consequence, energy is taken away from the fire, and the additional cooling effect prevents reignition. You see, due to the enormous increase in the volume of the water droplets, as they evaporate, the oxygen is displaced at the source of the fire, and the fire is extinguished. During this process, the oxygen content around the fire, and only there, is below 21%. And it is this low oxygen content that suffocates the fire. This is called the local inerting effect. Further away from the fire, the oxygen content is well above 21%, which means that there is enough oxygen available for humans. However, The droplets do need a fire of a certain size. Fact is that water mist systems may have a bit of an issue with small fires because these fires do not have the strength or the force to evaporate the droplets. But still, the system will be able to keep the fire under control until, for example, the fire brigade arrives. When it comes to the benefits of water mist, I would like to highlight the diversity. I have mentioned that water mist systems produce very small droplets. As a result, we have a suppressant agent that is applicable on a broad range of fire types. The reason for this is that the droplets turn into steam. This does not happen with sprinkler systems. In the chart, you can see that water mist ticks nearly all the boxes. In fact, no other kind of fire suppression, fire extinguishing system ticks more boxes than water mist. Regarding the electric and cooking oil fires, we strongly recommend that, of course, experts should install the fixed systems, and what is more important and maybe less obvious, hand fire extinguishers should not be placed into the hands of amateurs. The reason for this is that the direction in which the nozzle or nozzles point is crucial, because they should not point directly towards or into the fire, because we are not looking for the effect of the water extinguishing the fire, but the mist. So you need to provide a setting in which the droplets can turn into mist. And as this mist sinks down onto the fire, it suffocates the flames. Next, I would like to stress the eco-friendliness of water mist systems. In the world we live in, this is an important aspect. Technologies that are sustainable, environmentally friendly, eco-friendly, are vital and essential because they do not put pressure on nature, for example, do not deplete the ozone layer. So now what makes a water mist system eco-friendly? First of all, a water mist system obviously uses water, and what is more natural than water? And then a water mist system uses less water, up to 85% less water than a traditional sprinkler system. Then you have less material due to, for example, smaller pipes. We recommend the use of stainless steel for components that come into contact with water to avoid corrosion and thus contamination, and to support the longevity of the systems, which in itself is a sustainable and eco-friendly approach. The other thing about stainless steel is that it can be reused and thus be reintegrated into the life cycle. And you may be aware of the cradle-to-cradle approach that strives for a system that does not produce any waste at all. Then I would like to point out the reduced water damage, which means that after a fire there is less debris that has to be disposed of, plus in consequence there might well be less downtime for businesses. Another challenge is the disposal of the residue after fire incidents in hazardous areas like the nuclear industry and in pharmaceutical and electronic manufacturing. When a fire breaks out in such areas, this can result in the release of many different toxins and chemicals from the fuel of the fire and all the gases. The fire water gathers these substances and has to be picked up and disposed of after a fire, which is a difficult job that becomes the easier the less water there is. Another slide about the benefits of water mist, and this is basically a summary of what I've already said, plus there are some additional points. With a water mist system, you need less water, less material, less space, and in consequence, your costs are lower. I have explained that water mist systems produce the heat and the oxygen. Water mist does not harm humans. Here we sometimes have a misunderstanding. People think that if water mist systems suffocate a fire, they could also suffocate a person. But you remember the local inerting effect, which I explained earlier on. The oxygen content only around the fire is below 21%. Further away from the fire, the oxygen content is above 21%, which means that there is enough oxygen available for humans. Okay, so I've mentioned the local inerting effect. Water mist systems are easy to retrofit, and especially when it comes to historic buildings, clients often ask for effective but also invisible systems, and that's no problem at all. A water mist system can easily be extended. The cooling effect prevents reignition. Technology is proven to international standards and guidelines and is therefore ready to use. Overall, water mist systems are flexible, versatile, reliable. For every water mist system, there is a DIOM manual. The letters DIOM stand for design, installation, operation, and maintenance. This manual is the manual provided by the manufacturers, who obviously know the systems like nobody else does. So whoever has a water mist system installed gets detailed instructions for that specific system. And then there is obviously the eco aspect that I have already mentioned. Here you can see that water mist systems are installed and used basically all over the world. Famous buildings or spaces that are protected are St. Patrick's Church in New York, in Manhattan. Then there is La Scala in Milan, the famous opera house. Then we have here on the list the clock tower in Mecca, the Eurotunnel, the underground tunnel that connects Great Britain to the continent, and there is water mist in space. Yes, further buildings and spaces are St. Mark's Basilica in Venice. Apparently Venice is water mist city. Then there is the archive at the Bodleian Library at Oxford University. Here in Hamburg, we have the Elbphilharmonie, which is a concert hall, which is still quite new. And then there is La Rinascente, a famous department store in the center of Rome. Plus, there are many, many, many other buildings that are obviously not famous and then not on this list. Now come a number of slides showing segments, key verticals, and applications. I will not go into detail. You may want to look at the list afterwards to get a better idea of where water mist can be applied. This presentation is available from the IWMA webpage, and you can have a look at the list then later on. Anyway, here you can see the land segments and key verticals referring to the building segment. What I would like to mention is that this list, as well as the others, are not exhaustive. Here the same thing for the industrial segment. And then there is also the marine sector. On the left, you can see the list that basically includes all kinds of vessels. And what I would like to mention here is that water mist was actually first relaunched in the 1980s as an alternative to firefighting systems in marine applications, which takes us straight to the history of water mist. Here you can see that it was back in 1880 when a water mist backpack system was developed to fight small forest fires. Between then and the late 1970s, there were only very few initiatives to further develop the technology. In 1978, two Swedish scientists, Krista Giselsson and Mats Rosander, published a book entitled Fundamentals of Fire, and they wrote, and I quote, "In future, a liquid, for example water, atomized to drops smaller than powder grains, will be the most important extinguishing agent against flames indoors, so-called mist." I would like to mention the Montreal Protocol on substances that deplete the ozone layer, as the phasing out of halon, which was then banned, was the beginning of the water mist technology as we know it today. And then, as it is often the case with technologies within areas like fire protection, it takes a catastrophe to create progress. The fire on the passenger ferry Scandinavian Star killed 158 people, nearly 50% of all people on board. The fire led to an improvement of IMO's fire safety requirements and installation guidelines, as well as to the development of fire test procedures for alternative sprinkler systems. Now, IMO is the International Maritime Organization. After the fire on the Scandinavian Star, the results of the research work, which had been carried out in Sweden since the mid-70s, were highly sought after, and the researchers were asked to present their findings basically straight after the fire. And this led to the founding of the first water mist companies, Ultrafog, and shortly after that, about 6 months later, Mariov, and both are members of IWMA, as are all these other companies. Obviously, private members are not listed here. This takes me to the end of the presentation. Here are IWMA's contact details. If you need to get in contact, have a question, have a remark to make, please do so. I wish you a good day. Goodbye.